We're going to start chapter 8 today. And chapter 8 is all about exponents. Alright, it's all about exponents and properties of exponents. And I will tell you, it's going to come up real short chapter. It's a short little unit we're doing. Don't be surprised when we're probably testing before you go on your 4-day break next week. Okay? So keep in mind that you will be testing next week sometime. And I have two properties we're going to start out with today. We have the one that we just demonstrated with our calculators. We have, for every non-zero number a to the 0 power is 1. Anything to the 0 power is 1. That's an easy property. The other one we need to spend some time with. Without reading this, we're not going to read this part first. I'm going to show you an example without a's and n's, and I think you'll get it better. So I want you to write this down for me. I want you to write down 2 to the negative 3rd power. Write that down on your notes right now. 2 to the negative 3rd power. Now this property, what it helps us to do is to get rid of negative exponents. Our goal with this property is to get rid of negative exponents. Okay? The whole goal. We can't have negative exponents, they're bad. Alright. So I'm going to show you how to get rid of them with this property. I want you to make 2 to the negative 3rd a fraction. How can I make that a fraction? Put it over 1, right? Okay. Okay, here's how I want you to think of the numerator and the denominator. Numerator's on top, right? Yeah. Denominator's on the bottom. We're going to think about it as downstairs, upstairs. I'm going to teach you a way. This is going to sound ridiculous. This is probably going to sound ridiculous to you, but it will help you remember what to do with this property. You got a party upstairs and there's a party downstairs. You got parties going on upstairs and downstairs. 2 different types of parties going on. We got the same house. We got a party upstairs. We got a party downstairs. If something, when I say something, meaning a person, but when I say person, I mean either a variable or a number, okay? When a variable or a number attends these parties, if they get a negative attitude, that means they have a negative exponent, all right? So anything that you see with a negative exponent has a negative attitude with the party that they're currently in. Maybe that's because they don't like that party and they're in the wrong party. And they need to go to another party to be happy again. So let me show you what happens. 2 to the negative 3rd, it's in the numerator, it's in the upstairs party, and it has a negative exponent, which means it's not happy.
So switch it and make it go to the bottom.
But that's exactly what we're going to do. We're going to send it down to the downstairs party. Maybe upstairs they have country music playing, and maybe downstairs they got like hip-hop, and they want hip-hop music instead of country.
Why do you go to the first?
That would be neat, you know. I don't like country. But anyway, so maybe 2's not happy. 2 needs to be moved. So what we're going to do is we're going to take 2 to the negative 3, and we're going to move it right downstairs. But here's the thing. There's nothing else on that numerator. Right. Since there's nothing else in the numerator, since we're moving the 2 to the 3rd power to the bottom, we have a 1 left up top. Okay? And then 2 to the negative 3rd power, when it comes to the bottom, it's 2 to the positive 3rd power, and it's happy again. We're happy. We're at the right party. Okay? So if you kind of think about it that way, I don't know, with most students that helps. So
you just say it doesn't like it.
So now we're happy, you know? So let's look at some examples with both of these properties, okay? All right, so example 1, we have 4 to the negative 3rd. So that's just like what I just showed you. 4 to the negative 3rd, we're going to make it a fraction. Then we're going to look at the 4 to the negative 3rd. It's clearly in the wrong party because it has a negative exponent. So it cannot stay upstairs. So it's going to go downstairs. But what are we left with up top? Nothing, so we put a 1. Think of it as like a spacer. We can't leave a numerator blank. So we have to put a 1 there. And then on the bottom, we're going to have 4 to the 3rd power because now we're happy again. Now, you still have to finish this, though. We didn't finish the one in the example, but we do need to finish this. 1 over 4 to the 3rd. We can figure out what 4 to the 3rd power is either by in your head or in the calculator. So we need to figure out what 4 to the 3rd power is. 64. So it's 1 over 64.
When
Leave
you,
it as
when
a
you
fraction.
switch parties,
That's all you do.
negative goes away.
Yes. Huh?
You just leave those.
Yes, you leave it as a fraction, guys. Leave it as a fraction. All right. So we're done with A. Letter B is negative 1.23 to the 0 power. What is that? 1. I bet you'd love a whole worksheet of just these problems, right?
Yes.
Okay, well, too bad. All right. So this is just the simple
She always gives us these simple problems.
I know,
Never
but
gives
it's,
them to
I
us
want
in-
you to understand the basics of this, okay? So let's just up it just a little bit here.
And then we're gonna go rocket science after this.
All right, we have 4yx to the negative third power.
Makes sense.
Now, here's the deal. That negative 3 power, this is where a lot of students go wrong. They think that the negative 3 goes with the y and the 4, but it doesn't, okay? There's no parentheses. So that negative 3 is only with the x. Do 4 and y have an exponent?
No.
What is their exponent if there isn't one? Do you guys know?
Zero.
It's not 0.
One.
It's 1. So what I want you to do to help you with these problems is go ahead and separate the pieces out because you have to look at every piece alone. 4 times y times x to the negative third. If we look at this in parts, it helps you. 4 has an exponent of 1. Y has an exponent of 1. So are 4 and y at the right party? They are. Is x at the right party? No. It's got to go downstairs. So on top, we still have 4y, so we don't have to do a 1 here. This time we're just going to do 4y. And then on the bottom, x to the third power. Now it's positive, so now it's happy and we're good. Huh? You leave, yes. Because we don't know what x is. If we knew what x is, we could plug it in and get a number, but in this case, when it's just variables, that's all we can do. That's the most simplified we can get there. All right, how about letter B? This one's a little different because we haven't had one where,
Just switch it.
Where's
Just
W
switch it again.
yeah, because w to the negative fourth is in the wrong party because they have a negative exponent. And they're downstairs. So what party are they going to go to? Upstairs. So we're going to move them up. W to the fourth power. And then we can put it over 1 if you want. You don't really have to. Because we don't, like, it's different with the numerator. With the numerator, if you take everything out, you have to have a 1 there to be a spacer kind of thing. But if you're going from bottom to top and there's nothing in the bottom, you don't need a 1 there. But you do in the numerator. So keep that in mind. So that's just W to the fourth power. All right, the next example. We have to evaluate these exponential expressions. So evaluating, what that means is we're going to be plugging numbers into the variables this time. But what I want you to do first is go ahead and get rid of your negative exponent. Before you start plugging any numbers in, let's take the expression 3m squared t to the negative second power, and let's go ahead and get things where they need to be. Let's get them to where they need to go. Yes, Nico?
It's 3m to the second
Uh-huh.
times parentheses negative 3.
We're not plugging numbers in yet. We're first gonna go ahead and get everything where it needs to go, okay? 3 has an exponent of what?
1.
It has an exponent of 1. Is it okay? It can stay where it is. M squared, can it stay where it is? It can. It's got a positive 2 power. It's cool.
Yeah, sure.
T to the negative second, though.
No.
No. It's in the wrong place, so we need to move it to the bottom. So we end up with 3m squared over t squared.
That's confusing.
Okay, what part's confusing?
This
You just move the T
We're
Yeah,
just
you just
moving what's
T
negative.
down.
Okay. Once you get all of this where it needs to be, then plug in your numbers. Now, what did I tell you a long time ago? When you have to plug a number in for a variable, what do you do with it? Put it in parentheses. So we're going to be sure to do that. So we have 3, and then parentheses. We're going to plug in what m is. M is 2, so we're going to put a 2 there to the second power. Over, t is negative 3, so we get negative 3 to the second power. So now we can actually simplify this. Now we can do something with these because they gave us a number for the variable. So we're going to do order of operations. Please excuse my dear Aunt Sally. Do we have any operations we need to take care of with inside the parentheses?
No.
Nope. Do I have exponents? Yes, that's what we're going to take care of first. The 3 stays a 3 because the 2 doesn't go to the 3. The 2 only goes to the 2. 2 squared is what? Times 4. Negative 3 squared is not negative because it's negative 3 times negative 3. 9. Okay. 3 times 4, we get 12. So we get 12 over 9. 12 over 9 will reduce to 4/3. We'll leave it in a fraction form. So our answer is 4 over 3. Okay. All right, let's go to the back side.
What?
There's another side to the notes. Page 2. Okay. Population growth. We have a biologist who's studying green peach aphids. Those are insects, by the way. In the lab, the population doubles every week. So they have these insects, and they double every week. The expression that models this is 1,000 times 2 to the W power. So that's the expression that we can use where W represents the number of weeks of this experiment, okay? And 1,000 is how many we started with. It's the initial population. So we're going to use this expression, and what it tells us to do in part A is to evaluate this expression for W equals 0. So what we're going to do is we're going to plug 0 in for W into this expression. So we have 1,000 times 2 to the W power. So we're going to replace W with 0. So we're going to have 1,000 times 2 to the 0 power. We're going to multiply or do our exponent first? The exponent has to come first. 2 to the 0 power is 1. So we get 1,000 times 1, which gives you 1,000. Now it tells us to describe what this value represents. The answer is 1,000 insects. What did we plug in for W? 0. So at 0 weeks, we have 1,000. So that's, which makes sense, doesn't it? So we started off with 1,000, and week 0 would be 1,000. Okay. All right, so let's look at the next one. They tell us to plug in a -3. Now, what's the -3 going to tell us with this type of problem? -3, it's number of weeks. What does that mean? If I'm putting -3 in for the number of weeks, what does that mean? Yeah, but what does it mean? Like, it was even before we started. It was like 3 weeks ago. Okay? So it's 1,000 times 2 to the W power. So we're going to put in a -3. So we get 1,000 times 2 to the -3rd power. Now we got a negative exponent to take care of. We always got to take care of those. If you have any negative exponents, take care of those first. Yep. This is unhappy. It's in the wrong party. We got to go downstairs. So we get 1,000 over 2. Instead of a -3, now our exponent becomes a +3. Which gives us 1,000 over 2 to the 3rd power is 8. Gives you what? 1,000 divided by 8. 125. So that means 3 weeks ago, if this model was the same, okay, 3 weeks ago, we would have had 125 insects. And by the time you get to where we started, they had 1,000. Okay. Now, all right, I want us to do one more example, just right up below this one, because I want to explain something to you that a lot of students are getting confused with. So find a blank space, and I want you to write down this problem for me. -3 raised to the -2nd power. Let's see, was that example 5? This is example 5. Okay, -3 to the -2nd power. What do we do? We'll put it over 1. Is the -3 happy? No. This has got a negative exponent, right? Well, when I move it downstairs, okay, I'm going to have a 1 on top. On the bottom, the 3 is still going to be negative. That's why I wanted to show you guys this. the base number, which is your big number in the power. You got the exponent and you got the base.
The
The
exponent's
base
gonna be
does not change sign. So this is still -3. The exponent becomes +2. So be careful with that. Do not change the sign of the base. Only change the sign of the exponent. And then this becomes 1 over...
-9.
It is -9. I want to show you something else here.
There's no percent.
There's no parentheses. -3 squared is saying -3 times -3, which gives you +9.
You have to add the negative later.
But if you have -3 squared, what you're saying is basically -3 times 3, which is -9. So that's the difference between having parentheses and not having parentheses. So keep that in mind because that comes up a lot in your
So
homework.
if there's no parentheses, then it stays negative. But if there are, then it goes
It depends.
If it's a positive or a even numbered power. Even numbered power. So that's the first two properties of exponents.
That was easy.
Thank you for listening.